Hello, my name is Keegan Hunt. Today, with the help of my partner Jocelyn, I'll be showing you how to make an Astable multivibrator circuit with a fixed output frequency and a 547 ohm current limiting resistance for an LED output. I will be showing you how it was made using the Falstad program, which is a simulating tool. As you can see, this circuit, we used 5 volts in order to create it on here and on the breadboard. You could also use 9 volts, but it will cause a delay in the LED's light. But as you can see, the 5 volt supply goes to the pin number 8 in the 555 timer chip, which is the supply voltage for the chip, and also leads to pin 4, which is the reset pin. It branches off into a 1000 ohm resistor in series with a 10,000 ohm resistor, which leads itself into a 100 microfarad capacitor, along with a wire that splits off into the threshold pin, which is pin 6, and the trigger pin, which is pin 2. Uh, what it does is it charges up the capacitor, and while it's doing that, it keeps voltage going flowing into the threshold and trigger, which is causing voltage to go through and come out the out pin, which is pin number 3, which leads to two resistors in parallel with each other, one being 1.2 k ohms and the other being 1 k ohms. If you do the math using the formula, 1 divided by 1 divided by 1000 ohms plus 1 divided by 1200 ohms, you get 545.5. When you factor in the 5% margin of error, that gets you into the goal range. And then, of course, goes to the LED to light it up, and then into ground. So what's happening down over here, though, is once the threshold has reached 2/3 of the supply voltage, it will stop the timing, which causes the trigger to stop receiving the voltage and putting it out to the out pin. The capacitor also releases all of its stored energy, which goes into the discharge straight through the 10,000 ohm, which goes through the 10,000 ohm resistor and into the discharge pin, which is pin number 7, which leads it to pin 1 ground, which of course goes to ground. The capacitor also goes to ground. Let's see it in action. As you can see, the light has turned off and on multiple times. And if we slow it down a little bit so we can see, when it's on, the capacitor is charging up. But once it's off, it's discharging and going into the discharge pin and into ground, as said. But when it's on, it's it's setting voltage to the threshold and trigger pin, which is causing the on state. So the threshold is met and it opens up essentially and stops giving it power. So, to further prove out the resistance, you can use an ohm meter to measure the resistance. Don't forget to disconnect and isolate the components you are checking to prevent any shorts or opens from happening. As you can see, it reads out to 545.5 ohms.
This is our breadboard design. We have two 1K resistors right here, a 10K resistor, and a 1.2K resistor right here. We have the LED, and then the capacitor and the 555 timer. So we have this capacitor connected to these wires right here so that the current can flow through to the LED to make it light up. The LED, we have this wire connected to it so it can be connected to ground. And then over at the end here, we have our little wires and the jumper cable so that when we hook it up to our 9-volt battery right here, it will light up. So let's do that right now. So I have the red one connected to the positive side of the battery, which is right there, and the black on the other side. And you'll see that it's starting to light up now.